All right, so we're continuing. Section 3.3, we're dealing with quadratic equations. The new part to this will be looking at graphs to solve quadratic equations when we get to page 2. And then the other thing we're going to do in this section is quadratic inequalities. And those are the two big things that we've got going on. So we're down to example 3. Example 3 is an example of a quadratic equation that is in this format right here. It's something squared equal to a number. So I'm just going to write a big X. It's something squared equal to a value C. So when I have something squared equal to a number, let me give you the simplest example, and then we're going to do example 3. Let's say that we have X squared is equal to 5. Well, what can I do? Well, in fact, let me even make this simpler. I said the simplest example. X squared equals 4. I could bring the 4 over. I could factor that. I could get my two solutions to this. But since it's in the format something squared equal to a number, what can I just do to both sides to solve this? Square root. Yeah, I can undo the square by taking the square root. So I'm going to do that. I've got the square root of X squared is equal to the square root of 4. There's 3 pages. But you got it last time. You were here last time. Here's the other thing we have to notice. When we go back up the ladder, we should get 4. Well, that means I can square a positive number and I can get 4, or I can square a negative number. So when you take the square root, this is always a principle. When you put a square root into a problem, there's always 2 values. There's going to be a positive value and a negative value. So that is kind of the key thing to remember when you put a square root in. This symbol right here, in case you haven't seen it, this is just me being lazy. Instead of writing out 2 values, I just put a plus and a minus, meaning there's 2 values here. And so the square root of X squared is X. The square root of 4 is 2, and I've got a positive 2 and a negative 2. Because if I square positive 2, that gives me 4. If I square negative 2, that gives me 4. Those are my 2 solutions. That's my solution set, plus or minus 2. Okay, that's the simplest type of equation, that is something squared equal to a number, which brings us to example 3. Example 3 says I've got X plus 2 squared is equal to 13. Is this in the format of something squared is equal to a number? Yes, it is. Okay, so we can take the shortcut on this one. I don't have to multiply. I don't have to bring the 13 over. You could do all that. It's just more work. So here's what I'm going to do. I'm going to take the square root of both sides. So again, I am imposing a square root on this problem. This is what I'm adding. So square root of this side, square root of this side. What's the square root of X plus 2 squared? What do you think? X plus 2. Since I have put the square root into this problem, I'm going to have a positive and a negative answer. And then the square root of 13. Can I simplify the square root of 13 at all? No, 13 is a prime number. There's no perfect square factors to deal with. So I'm just going to leave that square root of 13. Less arithmetic to do. I'm all for it. I've got one more step. I need to solve this for X. So I'm going to write down this step. I'm going to subtract 2 from both sides. And I've got X is equal to negative 2 plus or minus square root of 13. Those are not like terms. Don't add them. One has a square root, one doesn't. You can't smush them together. There's 2 solutions. There's the negative 2 plus the square root of 13 solution, whatever value that would be. And there's the negative 2 minus the square root of 13. Those are here's my set. My 2 values. All right, so you are going to do exercise 3. It's essentially the same thing, just slightly different value for you to deal with. All right, I'm going to take the square root of both sides. So square root of the left, square root of the right. Square root of x squared. Thank you for being awake. And now on the other side, this is a quick review of what we talked about in the very first section of this unit. Square root of a negative. Square root of negative tells me I have what? Imaginary number, imaginary unit, I. And then what's the square root of 36? 6. And since I imposed the square root on the problem, I put that in there. There's a positive and a negative solution. And so here are the two solutions, plus or minus 6i. It is possible to get imaginary and complex solutions to these problems. Here's the last one, exercise 4. Do the same thing. Solve this. You've got 2x minus 3 squared equals 10. Solve that. Find the two solutions. All right, once again, this is the third and final example. If I've got something squared equal to a number. And so the shortcut to solve when you have that is you are going to take the square root of both sides. Hopefully that's what you did. And on the left side, the square root of 2x minus 3 squared is 2x minus 3. Voila. And then on the other side, well, I've taken the square root, so I do a plus or a minus. Okay, that is required. Don't leave that out. And then square root of 10. I can't simplify square root of 10. There's no perfect square factor of 10. It's 5 times 2. It's not super interesting, so we'll leave it square root of 10. I'm not interested in a decimal approximation. You don't need to get your calculator out on it. Then you've got 2 steps. You're almost at the finish line. So first thing is I'm going to add the 3 to both sides. So I get 2x is equal to 3 plus or minus square root of 10. Again, do not add these. These are not like terms. It's not 3 times the square root of 10. It's not square root of 13. Okay, it is 3 plus or minus square root of 10. And then the last thing is I'm going to divide by 2. And when I divide over here, you divide the whole thing by 2. Not just the 3, not just the square root of 10, the whole thing. And so my solutions are 3 plus or minus square root of 10 all over 2. I'm going to put that in some squigglies. And I'm done. Okay, so what happens next is what happens if I can't factor? What happens if my equation is not given as something squared equal to a number? And this brings us maybe to the source of some of your bad algebra dreams, and that is the quadratic formula. The quadratic formula will solve any quadratic equation, no matter what. So I've left you a little room to write it down there. So the quadratic formula, here's the key. have to put your quadratic equation into standard form, meaning you have to do all multiplying, you have to do all collecting like terms, you have to get everything on the same side, it has to be equal to 0. So once you know what A, B, and C are, A is always going to be the number in front of the x squared, B is always the number in front of the x, C is always the number added on, then we can get the solutions. Who remembers the quadratic formula? What's it?
Plus minus b minus square root of b squared minus 4 multiplied by a squared.
One little thing wrong. What's that? Yeah, so what you said this.
Yeah.
I'm going to disagree with you on that. Okay, so just a minor thing, but we need to correct it. The plus or minus goes in front of the square root. Okay, and just like over here, the plus or minus, and then the b is just strictly negative. Okay, so just a little sign thing, but this is the quadratic formula. It always works. Okay, no matter what. So if you don't remember how to factor, okay, that's fine. If you don't like taking the square roots of things, that's fine. You can always get your quadratic equation into this format and use the quadratic formula. Again, my assumption is you've seen and used this before. It may have been a while, okay? So your recollection might have been a little hazy there, but now that you've seen it, I'm hoping you remember it and remember how to use it. So we have 2 exercises I'm going to have you do. We're going to do them one at a time. So I would like you to use, God bless you, I would like you to use the quadratic formula, please, to solve exercise 5, x squared minus 4x plus 2. I just want to make sure we're all working in the same direction. What is the value of A you're plugging in? What's the value of B you're plugging in? That negative is important. What's the value of C you're plugging in? Okay, keep going. Just want to make sure we're all doing the same thing. I'm going to get started plugging and chugging. If you're still working, keep working. So all the challenges here is putting the right number in the right place. So it's negative b. Well, if b is negative 4, what's negative b going to be? Positive. Plus or minus the square root of b squared. Well, negative 4 squared, negative 4 times negative 4 is 16. Minus 4 times a, which is 1. C, which is 2. All over 2 times a, which is 2 times 1. Okay, so we've put the appropriate number in the appropriate place. Anybody got a question about why I put a particular number in a particular space? So I've got 4 plus or minus, underneath that square root, I've got 2 times 1 is 2. 2 times negative 4 is negative 8, so 16 minus 8. The rest of this is just a little bit of arithmetic. So underneath the square root, I've got 16 minus 8, which is 8. One more thing to do. 8 has a perfect square factor. What's the perfect square factor of that? 4. Okay, I can simplify this just a little bit. So I'm writing out all the steps. If you can consolidate some of these, that's totally fine. 8 is 4 times 2, which allows me to take the square root of the 4. Square root of 4 is 2. And the very last thing I can do now is I can distribute this 2, and I can reduce the whole fraction a little bit. Okay, so there's a little bit of number magic going on here at the end of this. I had to simplify this radical so that I can have the ability to divide that 2 in and distribute. So when I do that, 2 goes into 4 2 times. 2 goes into 2 once and leaves me square root of 2. So there is my, I'm just going to be lazy and throw some squigglies around it. There's my solution set, 2 plus or minus the square root of 2. So I'm anticipating probably some of the challenge, if you were challenged by that, was at the end here with the simplifying the radical. We talked real brief about that on, I guess, the end of last week when we did section 3.1, and we talked about complex numbers and simplifying those. So go back in your notes. We'll always look for a perfect square factor. Please do exercise 6. This will be our last problem reviewing our solving of quadratic equations. I'm just going to get started plugging and chugging. A is 2, B is -1, C is 4. And so my quadratic formula tells me negative B. So again, B is -1, so a negative B is a positive 1. B squared, -1 times -1 is 1, minus 4 times A, which is 2, and C, which is 4, all over 2A, 2 times 2. Underneath the radical, 4 times 2 is 8. 8 times 4 is 32. So I have 1 minus 32. And 1 minus 32 turns out to be -31. So the good news is there's a lot less simplifying on this problem. I only have one thing under the radical I have to simplify. What is that? Yep, the negative becomes an imaginary number. The 31, that's a prime number. There's no perfect square factor. There's nothing to do with that. So this is going to be 1 plus or minus I square root of 31 over 4. And then the last thing is, since this is a complex number, it's the same thing I told you when we talked about dividing complex numbers. The very last step is let's write our answer as a complex number with a real part and an imaginary part. So I'm going to take this 4, I'm going to distribute it into both parts. So I've got my real part is 1 over 4. plus or minus, and then my imaginary part is the square root of 31 over 4, and I'm going to put the I off to the side. There are my two complex number answers, and I'm going to put it in a squiggly, and there's my solution set, both of them. Yes? I am not super concerned about that. The only thing I would ask you not to do is to make sure that you don't put the I under the radical or in the denominator. I've got mine off to the side, but if you put it in the numerator, that's fine. If you put it out front, I don't mind that in this class, since we're kind of just starting to really work with them a lot. Okay, great. All right. Before we move on and finish out 3.3, questions, comments, concerns? Yes. The point, well, that can be one of the things. When we set an equation equal to 0, it's called sometimes called the root or the x-intercept or the solution. So yeah, it can be a tool for graphing. Excellent. All right, again, I'm just going to repeat this one more time before I move on. If this first page was not as much review as I'm assuming, then please email me, stop by the office. Let's make sure that we get you some extra practice, because I don't want this to be a concern on the test. Okay, I'm going to put some solving on the test, and I'm hoping that that'll be nice and relaxed and a way for you to get some good points. All right, so flip to page 2. I'm going to do that as well.
Okay, so some stuff that I'm assuming is probably not review for you. In intermediate algebra, we do not talk about what's called the discriminant of a quadratic equation. There are situations when you get to somewhere, maybe it's physics, maybe you're going engineering or something like that in your future. There are situations where you're not super concerned about the solutions of a quadratic. You want to know what kind of answers. Like, is this a good equation that's going to model things for you? And so there are situations where you just care about what's called the discriminant. The discriminant is the math word for this thing right here, b squared minus 4ac, the stuff that is underneath the radical in the quadratic formula. So if you want to know what kinds of solutions you're going to get from your quadratic equation, you can just evaluate the discriminant. And if the discriminant here, if b squared minus 4ac, if that thing underneath the radical, if it's greater than 0, meaning it's a positive number. Okay, so if you're not super good with the math terminology, when I write something is greater than 0, what I'm saying is it's a positive value. So if the discriminant is a positive value, what that means is I am going to have two real valued solutions. It also means graphically the parabola goes through the x-axis. Okay, those two real solutions, just as was asked a moment ago, would be the places where the graph goes through the x-axis. If the discriminant is equal to 0, b squared minus 4ac, the thing under the radical, if it's equal to 0, you have one real valued solution. What that means is your vertex is on the x-axis, that the parabola touches the x-axis in one place. That's why there's one solution. And then if b squared minus 4ac, if that is less than 0, meaning it's negative, well, we saw that with this problem right here. This one had a negative discriminant, right? Negative 31 would have been the value of the discriminant. That tells me that I have two complex solutions. And graphically, what that tells me is the parabola does not go through the x-axis. It's aimed away from the x-axis. So just the discriminant is not super hard to work with. You just got to remember that it's the thing underneath the radical. So if you would, for me, exercise 7, I've given you a quadratic, and I just want to know what kind of solutions does exercise 7 have. You do not need to find them. You just need to evaluate the discriminant for me, please. All right, so I'm going to get started. B squared minus 4AC. Well, let me come over to my quadratic. The value of A is 2. The value of B is equal to positive 3. The value of C is 5. So B squared, 3 times 3 is 9, minus 4 times A, which is going to be 2. C is going to be 5. That's 9 minus 5 times 2 is 10. 10 times 4 is 40. So it ends up being negative 31, ironically the same as the last problem right there. And so that tells me what are my solutions to this quadratic equation. Yep, 2 complex solutions. Perfect. So I think I don't have more examples on that figuring. If you can use the quadratic formula, the discriminant is just a little piece of it that you are evaluating. So it's just a matter of remembering that and remembering what it is telling you. If you get a positive value here, 2 real solutions. If you get 0, there's only 1 real solution. And we got a negative. So that means there'd be 2 complex solutions if I solved it. Example 4. All along in this class, we have been solving, or excuse me, we've been reading graphs. It's an important skill for this class. It's something we focus on over and over. So we are going to use this graph of this parabola, this quadratic, and we are going to solve an equation, and then we're going to introduce an inequality here before we do those analytically. So here is my quadratic. Here's what I want to know first. Where is the function f of x? Where is that equal to 0? Now remember, I'm going to say something I've said every time we start reading graphs. This notation, f of x, that is referring to what values? The y values. Function notation is just a fancy way to write my y values. So I want to know, where are my y values 0? What are the solution? What's the solution or solutions to this equation? So somebody give me one of them. What was that? 5, sure, right here. I'm just going to make a nice purple dot right there at 5. That is where the parabola goes through the x-axis. That is one of the solutions to f of x equal to 0. What's the other solution? 1. Yes, I'm going to make a nice purple dot right there at 1. So I'm going to write my solution set. Okay, there we go. It's not an interval. We solved the equation. Okay, it is 2 distinct values where the graph goes through the x-axis. You with me so far? Anybody confused, bothered, or worried? Okay, then do me this favor. We'll come back to the inequality in a moment. On exercise 8, the one right next door, do the equation. Solve when is g of x equal to 0 on that one. All right, tell me one of the solutions. Okay, I heard -6. And then I also heard somebody say -4. So you gave me both. I'm going to put some squigglies around it, braces. There we go. Anybody not know where to look for the solution? Can I put 1 or 2 of those on the test and hope that you're going to get good points for that? Okay, I'm going to feel good about it. I know you're nodding, but every class nods, okay? And I just want to make sure that you mean it. All right, so now I'm going to go back to my example. F of x is less than 0. So again, f of x, remember function notation means my y values. So don't tell me, I don't need any numbers, but describe for me where on the graph, where am I looking that f of x is less than 0? On the sides, is f of x less than 0 on the sides? No, that's f of x. If I asked where is f of x greater than 0, you'd be looking on the sides. So I'm looking where? The bottom, the middle. I'm going to trace it with my beautiful purple pen. Okay, this is where I'm looking. Those are the y values that are less than 0. So remember, I now want to give the x values that produce those y values I just traced in purple. I'm giving the x values, I'm giving the interval that produces those y values. So where does this interval start? Where do we start being negative? At 1? Where do we stop as I trace the y values? Where do we stop being negative? At 5. Last question. On the sides of this interval, am I going to use parentheses or am I going to use brackets? Okay, I heard both. Okay, so what tells me what to use? What do parentheses tell me about my interval? Parentheses mean what? Open or close is what the parenthesis or bracket tells me, and I use parentheses when there's no equal bar. And then I use brackets when there is an equal bar. Okay, so this one, do I have an equal bar right here? No. Nope, so I'm going to use parentheses. There's my interval. It's all the numbers, all the x values from 1 to 5, but I'm not including the endpoints because I don't care about where it's equal. All right, I would like you on the example right next door, do both of the next problems, both of the inequalities. Where is g of x less than 0? And then where is it greater than or equal to 0? Okay, so g of x being less than 0. On this one, the g of x is less than 0. I'm going to trace it in green. It's less than 0 on the sides. Oh, I forgot to tell you, and I'm sorry, on the thing I use to make these graphs, it won't put arrows on the end. I'm assuming that there's arrows here, and I'll mention that before the test. If I ever want there to be a starting and stopping point, I will make nice bold dots so that you know, I know there's going to be no tricks or gimmicks about that, okay? So that's just a product of the website I use to make these graphs. It doesn't do the arrows on the end. I wish it did. Okay, so less than 0. So where does this start? What's the lower bound of where this starts being less than 0? Yeah, negative infinity, way to the left, forever ago. And so now, where, as I trace it, where does it stop being less than 0? -6, yes. And what am I going to put on both sides of that interval? Okay, parentheses. We always put a parenthesis at infinity. And then since there's no equal bar, I put a parenthesis at the 6. I'm going to use a union because I noticed that there's another side to this. Where does it start being negative again? At -4. And then what's the upper bound of it being negative? Yeah, it never stops. Okay, it never turns back around. When you take pre-calculus, you'll talk about cubic functions and functions that have a power 4, and there's a relationship between the exponent and how many times the functions curve around, and it's really fun and cool, and we don't get to talk about it here. So there are functions that can curl back around, but not quadratic functions. And so again, I'm going to put a parenthesis on both sides. Now the part that I've left red, that's the part that's bigger than 0. It's above the x-axis. So again, I'm hoping this is a nice, clear question. If it's not, let me know. Where does this start being bigger than 0? -6. Where does it stop being bigger than 0? -4. Great. And what am I going to put at both ends of that interval right there? Why am I putting brackets? Excellent, because of the equal bar. Beautiful. All right, we're flipping to the next page. I've got another example, just because reading graphs is important and it's sometimes a stumbling block for students. I would like you, again, assume that there's arrows on the end of this graph. Okay. And solve all three, the equation and both inequalities, please. All right, so looking at my graph, where is it equal to 0? Well, it's equal to 0 where it goes through the axis. So on the left, that is -4, and on the right, that is +2. Make sure your notation is good. There will be a deduction, okay? Even though I know you know what you're talking about, you put braces around the equality. That is not an interval. That is 2 distinct points, okay? The next two will be intervals because they're inequalities. Where is this less than or equal to 0? Well, it's less than 0 when it's below the x-axis. So that is this middle loop right in here. So it starts being less than 0 at -4. And then you curl around and it stops being less than 0 at 2. And then one more time, just so I can feel good and secure, what am I going to put at both ends of that interval? Okay, great. I'm glad to hear that we're feeling confident about that. And then where is it bigger than 0? Well, this one's bigger than 0 on the wings. And so that is -infinity to -4. And then union 2 to infinity. And because there's no equal bar at the -4 and the 2, I'm going to put parentheses. And then we always put parentheses at the infinity regardless of if there's an equal bar or not. Is there a question, comment, concern about reading the graphs? You will make me super happy if you do as well as your confidence tells me on the test. I will love that. All right, so the last thing we have for section 3.3 is we can see graphically what it means for my to solve the inequality, whether it's greater than or less than 0. We're talking about where is the graph above or below the x-axis. So now I want to do the same thing. I want to answer the same question, but I want to do it analytically. So this time I'm being given a function. I want to know when is this less than 0. Okay, so here's the deal. We are going to solve inequalities many times in this class. We're going to solve quadratic inequalities here. In the next unit, we're going to solve rational inequalities. Then we are going to solve logarithmic inequalities. We're going to do all sorts of fun inequality stuff. It's always done the same way. So I know that these are probably going to be pretty simple or pretty easy problems for most all of you. I'm asking you, please, to learn the process. If you learn the process here with a quadratic function, which you're pretty used to, then it'll be easier to apply this process when you get to equations and inequalities that we haven't yet talked about. Okay, so my point here is I want you to learn the process. And so here is the process for solving any sort of inequality, but in this case, quadratic inequality. The first thing I'm going to do is I'm going to solve the equation. Okay, I'm going to solve the equation. Just like we did, I'm just going to slide this. I'll slide it back in a minute in case you're not finished. Just like we did, there's a reason why in each of these examples, the first thing I asked you to do was solve the equation. We solved the equation so that now we knew the boundaries of where things are going to be less than or greater than. So we are now analytically going to do the exact same thing that we just did graphically. We're going to figure out what are these points where the graph goes through the x-axis. Okay, so I'm going to come back down here, and now I'm going to just say, okay, x squared minus 8x minus 20 equals 0. I'm going to factor this because I intentionally made it factorable, but if you didn't see that or you don't trust your ability to do that, you can use the quadratic formula. It works always. Okay, so I'm going to factor this though, just because it takes a little bit less time. X squared, my firsts are x and x. And the two factors of -20 that add up to -8. In fact, I think we did this one on the front page, -10 and +2. So when I set both of those equal to 0, x minus 10 equals 0, x plus 2 equals 0, my two solutions are 10 and -2. I'm not going to worry about writing those as a set because I'm going to use these. If we were done, we would write it as a set and we'd move on to the next problem. The second thing I'm going to do, This is what you're always going to do. Anytime in this class you're asked to solve an inequality of any sort, you are now going to draw a number line. And I'm just going to put in parentheses. We'll come to understand this later a bit more when we get to different types of functions. This number line represents your domain. You don't have to remember that now. I'm just making a little note so I can feel like I'm doing a thorough job as your math instructor here. So the domain of a quadratic is negative infinity to infinity. There is no limitation of the domain. So I am going to draw a number line here that represents negative infinity to positive infinity. And what I'm going to do is I'm going to represent on that number line the two places where it's equal. It's equal at -2 and at 10. Number order on the number line is very important. Are you tracking with me? I'm just going to slide back to the graph up above. I'm just trying to show you what we're doing analytically and how it relates to what we've already done. So what I've done is my number line now represents our x-axis on the graph. Okay, that's what we've done. We've got the two places where it's equal to noted on the number line. And so what we're going to do, our final step, is I'm going to show you the way to figure out, okay, in each of these intervals now that we've created, is the graph above or below the x-axis? That's our goal, is to figure out this information right here in a way that is nice and quick and clean to do. And so what the third step, the last step we're going to do is we're going to test each interval. And what I mean by test each interval is I'm just going to pick a number in each of those three intervals. I'm going to plug it back into my quadratic, and I'm going to ask, did I get a positive value or a negative value? I don't even care what the value is. I just want to know, is it above the x-axis or is it below the x-axis? That is it. That's the only information I care about. So tell me, in this left-hand interval, that's negative infinity to -2, what's a value in that interval? Sure, -3. Or -6 or -100, whatever you want to use. It doesn't matter. Okay, I'm using a different color here just to represent that this is not an endpoint. I'm just notating what value we're using. And now I'm going to put -3 back up into my quadratic. So when I put -3 squared is 9. -8 times -3 is +24. And then -20. And again, we'll get a value here, but I don't really care what the value is. I just want to know, is it a positive value or a negative value? So 9 and 24 is 33, -20 is 13. That means it's positive in that interval. If you picked a different test value, you should have come to the same conclusion. We should all get positive on that left-hand interval. So now I understand quadratics, they're pretty much going to alternate. I totally get it. But remember the process. Practice the process so that when we get to things that don't always alternate, like the rational functions and other things, you're prepared to do this. What's a number between -2 and 10? What was that? -2 and 10. 9? Okay, let's use 9. Sounds great. I would have picked 0 because I'm mathematically lazy, but not everybody is mathematically lazy, and I love that. All right, so 9 squared is 81. -8 times 9 is -72, and then -20. So when I throw that into my calculator, 81 minus 72 is 9, minus 20 is -11. Again, I don't care about the value. I just care that it's negative in there. And then last but not least, what's a number in this last interval from 10 to infinity? Sure, 11 or 42 or a billion, whatever you feel like plugging into your calculator, it doesn't matter. When I plug 11 in, 11 squared is 121. -8 times 11 is -88, and then -20. And then 121 minus 88, I think that's 33. -20, that's 13, it's positive. So now, no matter what inequality I ask you to solve, you can solve it. I asked you to solve where is this less than 0? Which interval or intervals is my quadratic less than 0? The middle. This middle interval, where does this middle interval start? -2 to 10. What am I going to use at the endpoints to that interval? Why am I using parentheses there? You're 100% right. There's no equal bar. No equal bar. Boom. There it is. Well, bonus content. I know you love bonus content. Let's say that I had asked this. Okay, let's just pretend, since we've done all the work, there's no extra work to do here. Let's say I had asked, when is x squared minus 8x minus 20 bigger than or equal to 0? We're going to use brackets. And now which interval and intervals, represented down here on my number line, represents where it's bigger than? On the sides. So this first one is -infinity to -2. Union, and then the other side is 10 to infinity. And then, as I was already told, I'm going to change to brackets at the -2 and at the 10. Do I use brackets at the infinities? No, never. It's always parentheses, does not matter about the sign. All right, great job. So what I would like you to do, probably our last problem of the day, and then I'll talk about our test with you. Exercise 10. I believe exercise 10 does factor if you want to give it a whirl. But again, if you want to use the quadratic formula will always work. Base in there or something. All right, so you have two options to solve the equation. You can either factor, as I have, or you could use the quadratic formula. Again, I know you have all come in here from different instructors of either intermediate algebra or high school, so there's probably 3 or 4 or 5 different ways that you all know how to factor. I don't care which way you use, okay? So I showed you a way last time, not that you had to use that, but just in case you needed to be refreshed. So regardless, if you did factor this, it factors to these two factors, 2x plus 3 times x minus 7 equals 0. If you use the quadratic formula, you will get the exact same 2 answers I get. And that is what I get when I take 2x plus 3 and set it equal to 0 and x minus 7 equal to 0. So in the second case, x minus 7 equal to 0 means x is 7. In the first case, that means x is negative 3/2. So those are my 2 solutions. Those are the 2 points where the graph goes through the x-axis. Step number 2, I'm going to create a number line that represents my domain, and the domain of a parabola is negative infinity to positive infinity. And I'm going to put these 2 points, negative 3/2 and 7, on my number line. Now what I'm going to do is I'm going to test each of the intervals, and then I'm going to answer the question, where is this bigger than or equal to 0? Okay, again, I know that parabolas are pretty predictable, so bear with me. I'm teaching you a process. So negative 3/2, a number in the first interval is something like, let's say, negative 4. So negative 4 squared is 16 times 2 is 32. Negative 11 times negative 4 is plus 44 minus 21. So you probably did not pick negative 4 as your number from this left-hand interval. Whatever number you picked, you will come to the same conclusion though. Okay, so if you get a different conclusion, one of us did our arithmetic wrong. So I get 76 minus 21. It's something like, what, 55. The value doesn't matter. What matters is that it's positive on that end. In between, I'm going to pick 0. That is not what you have to pick, as we saw last time. When I plug 0 in, 0 squared is 0 times 2 is still 0. Minus 11 times 0 is 0. Minus 21. And so all that to say is I get a negative value in the middle. And then last but not least, I'm going to plug in 8. 8 times 8 is 64. Times 2 is 128. Minus negative 11 times 8 is negative 88 minus 21. And again, you throw that into your calculator, you get a positive value. That's the result. So to answer the question is, when is this greater than or equal to 0? Well, once again, it's greater than or equal to 0 on the wings, on the ends. So that's negative infinity to negative 3/2, union 7 to infinity. Because of the equal bar, I'm going to put brackets on those points of equality, and I always use parentheses on the ends. And that is that.